All right, we're going to do something kind of crazy. We are going to build an entire universe right from scratch. No matter, no energy, just a few simple but really powerful rules. This is the geometry blueprint, the hidden code that, believe it or not, constructs our entire reality. So let's jump in. It's a huge question, right? I mean, it sounds totally impossible. But you know what? In the world of geometry, the answer is surprisingly simple. And it all kicks off with a single spark of creation. And boom, here it is. A single point. It has no size, no width, no depth. It's just pure location. You can think of this as the fundamental atom of our geometric universe. Every single shape, I mean everything from the square on your screen to a skyscraper downtown, it all starts right here, from this one invisible spot. Okay, so we've got our first ingredient. Now, what happens when you have 2 points? Well, you connect them. And in that simple act, just like that, we create the backbone of all structure, the line. The moment you connect 2 points, you've made our first object with a dimension, length. This little guy is called a line segment. It has a clear beginning and a clear end. It's the first real building block we can actually, hold and use. But watch what happens with just a tiny change. A line segment is finite, right? It's like a ruler. A ray, on the other hand, starts at 1 point and just keeps going. Forever. This is our first brush with the concept of infinity, and it all came from just one simple connection. And once we have lines, they can start to interact with each other. They can be parallel, kind of like train tracks, just running alongside each other forever without ever touching. Or, and this is where things get really interesting, they can intersect, they can cross paths. And when they do that, something brand new is born. So what is that new thing? It's an angle. An angle is simply the space, or the turn, between two lines that cross. And by measuring this turn, we unlock a whole new language for describing the shapes all around us. First up, we've got the acute angle. Think of it as a sharp, tight turn. It's small, kind of pointy, and always less than 90 degrees. Then we have the absolute superstar of angles, the right angle. It's exactly 90 degrees. This is the perfect corner. Seriously, it's the angle of stability and construction. You'll find it in the corners of rooms, in books, on your screen. It's literally everywhere. And finally, to round things out, we have the obtuse angle. This one's a wide open turn, more than 90 degrees. It's kind of relaxed and spread out. So you've got acute, right, and obtuse. These three relationships are the foundation for everything we're about to build. Okay, so let's see how all these pieces come together. So far, we have points, we have lines, we have angles, but we haven't actually enclosed any space yet. With just one more line, a third line, we can finally create the first, and you could argue the most important shape of all. The triangle. 3 lines, 3 angles. It might look simple, but the triangle is the most stable and rigid shape there is. It's the reason you see it in bridges, construction cranes, and those cool geodesic domes. It's the true bedrock of structural design. Now, in our geometric universe, we need a way to say two things are absolutely identical. For triangles, we call this congruency. It's a fancy word, but it just means they are perfect clones of each other. Every single side and every single angle matches up exactly. The easiest way to think about it is like this. They're identical twins in the world of shapes. If you could pick one up and place it directly on top of the other and they match perfectly, well, they're congruent. This idea is super important for everything from manufacturing car parts to designing video games. And, get this, hidden inside every right-angled triangle is a secret code. It's a powerful rule that has fascinated people for thousands of years, the Pythagorean theorem. A squared plus B squared equals C squared. It sounds simple, but this formula is like a key that unlocks hidden distances. It lets us figure out the length of a diagonal, the height of a building, or even the path of a spaceship, all without ever having to measure it directly. How cool is that? Okay, so we've totally mastered the triangle. What's next? Well, it's pretty simple. We just keep adding sides. This is how we expand our universe from just one shape into a whole infinite family of shapes called polygons. The main thing about any polygon is just how many sides it has. 3 sides, that's our good old triangle. Add one more and you get a quadrilateral, like a square or a rectangle. 5 sides gives you a pentagon, 6 a hexagon, and so on and so on. These are the building blocks for honeycombs, stop signs, and the tiles on your floor. The pattern is so simple, but the variety of shapes it creates is absolutely endless. But There's one shape that's a total rebel. It doesn't play by the rules of straight sides at all. It's elegant, it's endless, and it's defined in a completely different way. I'm talking, of course, about the circle.
Notice something here? There's no mention of sides or angles. A circle is all about its relationship to one single point, the center. Every point on the edge of that circle is the exact same distance away from the center, and we call that distance the radius.
These three parts are basically the circle's DNA. You've got the center, which is its anchor point. You've got the radius, that constant distance to the edge. And then you have the diameter, which is just two of those radii, stretching all the way across. These simple parts work together to create its perfect, continuous form. So let's just take a step back for a second. From a single dimensionless point, we connected them to make lines. We crossed those lines to create angles. We enclosed them to build triangles, then a whole family of polygons. And then we broke all the rules to create the perfect circle. These aren't just ideas. These are the fundamental blueprints of our world. Everything, from the screen you're watching this on to the orbits of the planets, follows these geometric rules. They aren't just abstract ideas from a math book, they are a creative toolkit. So the final question is, now that you have the blueprints, what will you build with them?